When you think about the North Pole, you don't expect it to go anywhere, and you don't expect to change places with the South Pole. Our magnetic compass would be impacted and point towards the wrong way. We will need to update the GPS, navigation, and maps. Birds would be horribly confused. Although this sounds like some science fiction scene from a sci-fi movie, this is very much real. It happened before, and the process behind it may be a lot more dangerous than you think. It's not the reversal that is dangerous, it's the buildup process. During this process, the geomagnetic field that protects us from the sun's solar radiation drops to almost 10% of its current strength. It was one group of scientists in 2021 who predicted the climate shifts, mass extinctions, satellites being destroyed, electrical grids going offline, and deadly radiations showering upon us during this buildup process for 100 or maybe 1,000 years. This is dangerous, especially when we know we're a couple of hundreds of years away from our next geomagnetic reversal, which raises the question, should we be worried? Join us in this video to see when the next geomagnetic reversal is, whether it's going to be an apocalyptic scenario or merely just an impact. Let's start by understanding where this geomagnetic field comes from. Not every planet has this field. For example, our natural satellite moon doesn't have any. Yet, Earth does, which is a good thing because without it, life would not be possible. Thanks to this field, deadly solar radiation is deflected away, allowing life to get flourished without all that radiation breaking down our DNA. Scientists are still finding out the details on why some planets have field and some doesn't, but the current theory suggests that it's due to the Earth's core, a giant dynamo. In order to produce these fields, the core needs to be partially liquid, which is true in Earth's case. Above the solid, that is our inner core, the outer layer has a liquid. Now, another question that might raise, why does Earth have only one North Pole and one South Pole? Well, there has to be an extra force somewhere which directs magnetic fields in the same direction. This force is called Coriolis effect. As per this effect, a mass moving in a rotating system experiences a force acting perpendicular to the direction of motion and to the axis of rotation. Because the Earth rotates on its axis, the circulating air tends to deflect moving objects to the right in the northern hemisphere and to the left in the southern hemisphere. However, this process is very complex, and hence, it has constant changes in this field. This is the result in that in recent years, scientists have experienced the North Pole is shifting. Since 1840, when we started monitoring, it has shifted to almost 1,880 kilometers, leaving its position from Canada to Siberia. But what causes these geomagnetic reversals? Current theory suggests that it might be due to some interplay between the mantle and the outer core. This causes a fluctuation that disrupts the spiraling shapes of the core's flow. The magnetic field stops being unified, creating a huge mess fighting for the direction. Several poles might temporarily arrive during this process. While they settle down, there will be numerous times when the North Pole shifts towards geographical South Pole. This reasserting can take 1,000 to 10,000 years. Another theory points towards external influences, such as cosmic radiation, solar activity, and impacts from celestial bodies. That could influence Earth's magnetic field. For example, intense solar storms bombardment could disrupt the magnetic field and trigger a reversal. There is also this theory that talks about the changes in the Earth's tectonic plates, and the configuration of continents could influence the dynamics of the geodynamo and contribute these reversals. But why would this matter to us? Well, during that period, before the poles reassert themselves, poles drop its current strength by 10%. In theory, this could make us much more vulnerable to all the solar radiations coming towards us. You might see much more brighter auroras in the sky, and this could potentially increase the risk of skin cancers. All the circuits in our satellites would get fried up, and eventually satellites would fall on Earth. Power grids would be much more vulnerable to solar storms. This can be a serious threat to us, with almost no electricity, internet, or communication, impacting overall global civilization. But it could be worse than this. Recently, researchers from University of South Wales, Sydney, post that periods of significant environmental change, including mass extinctions, may coincide with Earth's magnetic field reversal. So how real are these risks? Honestly, it's a mixed reality. A point in our favor is, other than this recent theory, there are no other evidences to coincide magnetic field reversal with mass extinctions. It is possible that many reversals have come and gone without affecting any life on Earth. These magnetic changes would take many lifetimes to complete. Even at their fastest, for instance, if our satellite would not have any shielding, we will get the time to build it with better protection. If solar radiation becomes a risk, we can remain indoors more. Sunscreen becomes more powerful, if not to mitigate, but to protect us up to a large extent. In conclusion, the phenomenon of geomagnetic reversal stands as a captivating enigma in the field of earth sciences, weaving together intricate threads of geophysics, paleomagnetism, and planetary dynamics. As we peer into the depths of our planet's interior and reach out to the cosmos beyond, we are confronted with the awe-inspiring complexity of the forces shaping our world. Though meticulous research and interdisciplinary collaboration, scientists continue to unravel the mysteries of geomagnetic reversal, shedding light on its underlying mechanisms and broader implications for Earth's past, present, and future. From the swirling currents of molten iron in the Earth's outer core, to the dance of magnetic field lines extending into space, each discovery brings us closer to understanding the dynamic interplay of forces that govern our planet's magnetic field. Yet, amidst the quest for knowledge, geomagnetic reversal serves as a poignant reminder of the ever-changing nature of our world. It speaks to the resilience of life on Earth, which has endured countless upheavals and transformations throughout geological history. As we gaze upon the swirling auroras dancing in our polar skies, we are reminded of the delicate balance between cosmic forces and the fragile ecosystems that inhabit our planet. In the face of uncertainty, one thing remains clear. The journey to unravel the mysteries of geomagnetic reversals is far from over. With each new discovery, we are humbled by the vastness of the cosmos and inspired by the boundless curiosity of the human spirit. As we venture forth into the unknown, guided by the beacon of scientific inquiry, we embrace the challenge of unraveling the secrets of our magnetic past, forging a path towards a deeper understanding of our place in the cosmos. Let us know which of these facts intrigues you the most. Thanks for watching.